Swayam Prabha. Digital India. Educated India.
Okay, so far lot of theory, modeling and some applications also Professor Shizang has given, and now next 1 hour and also tomorrow first lecture and second lecture, all three is going to predominantly giving you the field oriented, and I am making it general coastal engineering, which also includes couple of coastal protection aspects. However, I am trying to correlate the so called the coastal process, which is nothing but the sediment transport, okay, in simple engineering sense. Of course, it has a very broader umbrella coastal processes, but in simple for our application I can put even it can be only sediment transport, and sediment transport happen for many number of reasons, either the natural or anthropogenic or changing the your climate change, so many other attributions that we can make it. All those things how it is affecting a particular system, and which has the major development like a port, one example. Second, and say if it is a coastal protection, how it is responding. I will not go detail about the more depth of the coastal protection, because Professor Sudhir will talk about the only coastal protection for first 2 hours tomorrow. And third, in a virgin coast something is happening, how we need to affect do that. And last, and one of the very sensitive regions, how we have to react. Everywhere the main thing is sediment transport or the coastal processes. Okay. So, that means I am not going to any of the equations, but you have to try to relate to the equations. I will also tell that another, and ultimately if you are providing a solutions, and I will not talk about say even the first part, I am not going to talk about any solutions about, but can you predict the particular coastal processes in that particular regime of what is happening? That is one of the very important thing. And if you are able to predict using the so called all the theory and modeling that you learned the last 3.5 days, then it will be well and good. Ultimately that is an achievement you are going to make it. Again I am stressing it in the first day, I am repeating it. Now if you are successfully capturing the qualitatively, you are good. Quantitatively if you are not doing, do not worry about it, but qualitatively if you are missing, your numbers are perfectly same, instead of plus you are getting minus, that is all, whatever the prediction you are having. So it is not useful for next step. So qualitatively even 100% your result is varying or 300% your result is varying, but still you are qualitatively same trend you are predicting, you are 100% you achieved the target from the understanding of coastal processes from that day that we have today. You should have a very clear thing. So that means if you are providing a solutions, that means how much you are confident, that depends on how much better qualitative understanding of the entire process. Okay, that is very important. So I am going to take up many aspects only on based on many of the things captured from the images or the satellite images or from the field measurements, and some of the field measurements are our own, some of the field measurements take it derived from the other projects done from different institutes. Now couple of slides, and say the coastal hazards or the even coastal process also we can say, and three sense: hydrodynamic scale, engineering scale and the geological scale. Of course, since we are not worried about the geological scale, the forces that we need to consider, because now the coastal processes there are two things, one is a driving forces, another is a material. Material is a sediment and vegetation predominantly. So the one side is forces, another thing is a material is going to drive it, and that I am interested in 0 to 100 years, not more than that. So day to day it is going to get affected based on the wave action, because what is your ocean wave period is 5 to 8 seconds, every wave of 8 seconds, every 8 seconds I can get one change. Then if I go to that storm surge, then within 3 hours I can can see a substantial change here 3 hours term. Then tidal cycle is 12 hours 25 minutes. So every 12 hours 25 minutes I can make another prediction. Then little higher 28 cycles of the tidal cycle we can get another prediction. So 1 year etc., etc. So many all these cycles that we can predict in the hydrodynamic scale, and altogether summing it up engineering scale. Now as a coastal engineer, you have to be very important thing, you are going to be or you should be happy with 1 year average rather than everyday prediction or everyday impact, which is a very important thing that you have to keep in mind while you are doing everything. 1 year average is good. This class average rank is B grade, I am very happy. I do not bother if some of your U grade, some of your S grade. That is what as far teacher is concerned. So all of your teacher in particularly the coastal engineering, you should be happy with the 1 year average, not everyday impact. After a cyclone, there may be a erosion, say for example 100-meter erosion, or I can put the other way, during a cyclone the substantial accretion at one point due to some reason, say at a bay 100-meter accretion. Always I put it on both sides because always somewhere in our mind that erosion is dangerous, accretion is a good, that one you have to remove your mind. Neither the erosion nor the accretion are neither good nor bad. It is based on the functionality or based on the requirement of humankind. Ultimately we are working for engineering. Once we talk about engineering, so it's everything is one way or another we are going to useful for the humankind. We are also talking about protecting the nature. Why? We need, humankind needs protecting the nature, ultimately we are going to get protected. So that is what we are going to protect the environment, not the other way most of the time. So that is a engineering sense. So and this combined one only we are going, you also listened in the last 3.5 days. So coastal processes predominantly it is going to affect, one is on the driving force, and that is energy, predominantly wind, wave, current and tide. That is a basically predominantly you are having it, and material predominantly sediment that we are talking about it. Sediment can come from the your rocks to the clay of any category, and vegetation on either it is a mangrove, and of course mangrove is not possible to grow at all the point where only the freshwater saline water will be there, that point of junction it can grow, otherwise so many other vegetation also possible. And the last one is human management, the way in which either it is a new project you are hindering a particular coastline or an existing one, how we are going to improve, all those coming to the picture, which also including the dredging. There is no structure, we are removing that dredging, or even artificial nourishment also a human intervention. You are adding a material, you are adding a foreign material particular location. So that means a foreign material may not fit into a particular area. So that is also be dangerous. So just to recap, now entire thing coastal processes is purely on the sediment transport. I think now you are familiar with the sediment movement along the coast or in the near shore. One is along the shoreline, which is called the longshore drift, okay, or called also the littoral drift. Other one is perpendicular to the coast, onshore, offshore or cross shore drift, sediment transport. So these two are two different distinguished phenomena. Tomorrow the last one, the field measurement, and we tries to quantify how much is cross shore, how much is along shore from the purely based on the field measurement. So and of course this was a very difficult task, and but based on the in Mahabalipuram coast during the monsoon, both the things happening, how to we can quantify how it is going to affect our entire coastal processes, which is very important. So that is what understanding these two are very important, even though both are occurring together, but always we do the design for one of the thing, always we cannot make a solution for both always. Now one by one I am going to take, and how many of you are from Chennai region, or all of you are familiar with North Chennai, Ennur, okay. Now and we have two major ports nearby in the Ennur, which is called the Kamarajar port, and just north of it will be the Kattupalli port. If you see this distance is hardly 2 km or 2 to 2.5 kilometers only, which is very, very close. Both the northern breakwater of the Ennur Kamarajar port to the southern breakwater of Kottapalli port. And this stretch, what is happening along this stretch from Ennur Creek to this area? South of this Ennur Creek, Professor Sundar will talk to you tomorrow, because that is a many decadal problems and how it has been changing coastal region, how it also got protected, and with the way human intervention to the protection, what also happening as on today, he will talk about it. So, I am going to talk just north of it. Okay. Now, and of course, this is overall the longer stretch of the coast, what we are going to focus on from the Ennur Creek to the say north of the Kottapalli. This is the present scenario. Now, I am coming from the time slot 1985, when there was no development at this region. Say entire region is virgin coast, entire region is virgin coast in 1985. Next time slot nearly after 10 years, 1998, almost it retained the same shape, because development was yet to start. 1998 we started planning for the so called the Kamarajar port at present, or Ennur port. Now, with 1999 almost nearly they are completing this port, both breakwaters. So, immediately in the east coast of India, predominant sediment movement is towards north, that is the net transport is towards north. Whenever there is a protrusion, you can see a accretion on south and erosion on the north. Now, this is 1999, as soon as very immediately after the construction of this breakwater. This is the north, correct? Of course, there is a accretion started at the south, perfectly okay. Why accretion has started in the north? It's nothing to do with what you learnt in the 3.5 days. It's more than that. Okay. Now, and here there should be an erosion only, because if it is a west coast, definitely you can scratch your head whether our prediction of the net sediment movement of north is good or not. It's a difficult thing. But during the planning of the Ennur port or the Kamarajar port, whether the layout is good or not, I am not going to comment, because so many debate has happened, etc. But they made one of the very wise decision. All the capital dredging at this point, they made a large sand bank on the entire northern coast. That means about nearly 3 to 4 floor high, 10 to 12 meter high sand bank. They dumped all the sediments on the coast, and it is disturbing. That is what you are seeing, the loose sediment there. All the sand bank has been slowly supplementing to the erosion. Actually, this is one of the concept of the artificial nourishment. Artificial nourishment, one, we are supplementing the material every year, and otherwise we create a bank there, sediment bank. So, that has been supplementing, slowly it has come, and if from 99 or about 2000 to 2004 or 5, if you see this cross section, the shoreline, then there will be a sandbed. This is your entire sand bank at this area, slowly it sacrificed into the sea, because erosion is inevitable, and this is made here like a sand bund below the location, which sand bund most of the time it will be visibly seeing this region. And this is only because of this artificial nourishment, which was pre-planned much earlier in the Ennur port. Okay. Now, in the sediment transport, most of the time the prediction of erosion or accretion in this region will always fail if you are not taking this as a source function, which is easily possible theoretically. You can assume a source function in the numerical prediction modeling tool where you are giving the material which is working to complement the erosion at this point. So, this has to be taken. So, that means you should have a prior knowledge of what you are going to do it. Okay. Sediment transport modeling is not a blind, where you cannot give some input, you will get any input, you will get some output. That is what any sediment transport model, whatever that good commercial packages, and if you are not thinking, whatever you are going to get is only junk. You have to be very careful. So, here because most of the prediction they will not get a very good result in the modeling. Though here also 2001 you can also see a good amount of sediment, it is not the accretion due to the wave action, it is due to the nourishment which is because of the sand bank. Slowly this sand bank has died down because the rate at which the sediment the erosion is here in along the east coast of India, particularly nearly 0 at Nagapattinam to the maximum at the near the Paradip or north of the Paradip. Slowly it increases, nothing will compensate. So, this sandbank has slowly gone down, but luckily once erosion also started, because most of the time sandbank has come in about 2007 etc., we started seeing the erosion also. Luckily then 2011 the construction of the Kattupalli port breakwater they started. As soon as they started the Kattupalli breakwater, large erosion, because the stretch is very small of only 2 kilometers. Only 2 kilometers. So, huge accretion has started. This huge accretion, immediate huge accretion is another that also has another reason, that the mouth is in the other direction. Already all the sediments started bypassing this one, because you can see a the light color, because sediments are also the shallow point. It has started bypassing and going and it is got captured. And this sediment of course it is good in terms of the mitigating the erosion induced by the northern Ennur port breakwater, but this sediment also has made a devastating effect on CPCL intake. They constructed at 8 meter here. Once this breakwater has come, entire intake well got siltation for them. They could not operate it. So, then they have just pushed down further down into the deeper water. Okay. So, that is what I said, accretion also a problem. So, creation of erosion also a one solution engineering wise. Next they have completed the Kattupalli port breakwater also, then we started seeing the large erosion. The wise decision of the large sandbank done for the Kamarajar port was never envisaged, and it is not only never envisaged, there is a desalination plant in this area. They also did not allow them to keep so much sediment, even they did not allow the whatever the dredging they make, they are trying to dump it from the seaside. So, they did not want, because they have a intake channel here, they were afraid that their intake channel will get affected. So, that is also another reason that it is at present a sediment starving region. This is 2020 and 20, this is keep on going inside, the rate at which is an enormous rate, nearly 50 meter per year. And however, here if you see slowly it is building up, slowly building up. I am very happy in one way that Chennai land cost, if I compare, I am getting a very huge cost getting it back, but we are going to pay in a different angle, not the Kamarajar port, where is already they started filling the siltation within the Kattupalli port. Now, entire thing if you are modeling, because it has all the problems in this particular stretch, not even the southern part of the Chennai port, it is only sediment transport. You say artificial nourishment is there, and some breakwater is there, some protruding structure is there, dredging activity is there, and deposition is there. All the things whatever the sediment modeling that you learned, you can successfully apply it to this area. That is what I thought of explaining to you. Now, we try to see from the satellite and also tuned with the field data. See, most of the time satellite imagery analysis and it looks to be like a very easy to do. If you can easily do it, there are two aspects you have to do. One is benchmarking from the field data, that is also not sufficient, and your image has to be referenced. That reference is very, very important, and always there is a very simple one of the things is most of the images are 5 meter or 10 meter resolution, and even 2 meter is with reference to some fixed reference. So, 5 meter, if there is at your resolution, how can you predict a 1 meter per year erosion or 1 meter per year accretion? This is one of the greatest challenge question. But if you see all that research papers, they just produce even 50 centimeter or 10 centimeter erosion also. That is not at all possible from the images in one way. But if you make a geo-referenced with reference to another fixed object on the land side, you can make it with reference to a geo-referenced scale. Okay. So, that is always possible. However, field data, it is not for validation, field data is not for validation, you have to take this field data for tuning the parameters, calibration, validation is not a thing. So, tuning is also a part of the calibration, you have to make a calibration of the entire data set. So, we did a enormous amount of measurements, field measurement, we fix a transects from Yenur Creek mouth to the north of the Kattupalli port at many places, monthly, seasonally. We captured all the transects, how it is varying, say from April 19, February 20, 21, March 22, etc., different lines predicts the pitch profile. Pitch profile is nothing but we make a reference line on the sea line. One of the simplest reference line is a sandbar on the coast or on the land side. Most of the time you will not be seeing a visible sandbar. Sandbar is a feature, particular coastal feature. Many of the locations you will not see a referenced or the visible sandbar. You can make a benchmark line, from there all the transects are made. So, always you can see this is your at the sea front. This is say at say for example April 19, you can see a very distinguished berm. Assuming that this is at say elevation, say approximately this will be the your water line about 1.4 meter, this is your water line. There is a significant coastal berm that you can see at some point, and say in March 2022 you do not have any berm, almost relatively it is steeper, and similarly you can make every transect what we can do, and every transect will convey a different meaning. Say for example compared to here, say this is a transect 2, this is a transect 2, and if I am comparing transect 2 with say transect 5 which is on the north and south, there will be a significant difference, because already Kattupalli port breakwater has been influencing this region. You can see this part relatively a steeper coastline. Okay. So, water depth will be much higher, and this is predicting what is that major thing is about 1.2 meter and average tidal range in this particular region. That is also very, very important. Always capture the, are you capturing the low tide or high tide, which is makes a lot of difference. Both are very important, and for your calculations what are you trying to capture, particularly for 1.2 meter with a shallow depth, 1.2 meter with a shallow depth, and that means flat slope. 1.2 meter with a flat slope, even 1.2 meter can inundate about 20 meter into the land side during high tide. So, 20 meter from low tide to high tide, that will be a significant length in which all your sediment transport calculation can make significant variations. Most of the time what we do, that is sediment calculation, we take a mean sea level. Mean sea level is good if there is a steeper beach. If 1 in 20, then steeper beach, does not matter whether you are taking mean sea level, high tide or low tide, all your prediction will be one and the same. But if it is a 1 in say even 100 or 1 in 150, very, very flat beach, it makes lot of different if you take high tide line and the low tide line. Okay. So, that makes sense, that is what the tidal range with reference to a seabed slope, which is very important. And many times seabed slope we will be saying that if you are using the modeling, some of the tools, I think Professor Zhang has given you some of the tools algorithm. If you feel that the sensitivity of the seabed slope, you will not feel much. If you are taking 1 in 150, 1 in 100, 1 in 80, you may not feel much. That also depends on what is the parameter that you are going to do it. So, in the sensitivity with reference to what you are predicting, that you have to be very, very careful. Now, and another important thing is on the sediment segregation. Kottapalli and Ennur, if I see significant variation in the sediment transport. Entire Ennur region, one way or another, we have seen a coarser compared to the other area. So, entire this Ennur, where the settlement were there, it is been very coarse compared to the northern part on the Kottapalli area, where all are fine. And this sediment segregation is the natural way of the sieving, and once it is going to become a accretion coast due to any reasons, whatever may be the reasons, the ultimate, the retained sediments are only the relatively larger size. Smaller fine sediments in the particular medium will be getting slowly taken away to the other end. When that is on the happened in the Ennur, because another also reason is that Ennur already it was a eroding coast. Once Kottapalli coast has come, a new sediment only has deposited. That means new sediment means a larger particle only has deposited. The other way also I can argue in this particular case. But now coming to the Kottapalli, it is not only the fine sediments, okay, fine sediment, a coarse sediment also were there. But predominantly because of this entire spectrum, a kind of a well graded distribution, okay, this is a typical of eroding coast with lesser coastal sediment compared to the lesser coastal sediment compared to the fine sediment. Fine sediment will be more, and once fine sediment is more, it is subject to more erosion also. So, this will be a continuous activity or in the loop, continuously it will happen. So, sediment size also a very, very important part. Next, if you are calculating the longshore sediment transport, have you got some formula for longshore sediment transport? Okay. So, if you substitute take one formula, longshore sediment transport formula, substitute for different D, a fine silt, medium silt, coarse silt, and fine sand, medium sand, coarse sand. 6 category, you have a mean range. If you just Google it, you can get your mean diameter. You substitute and see what is happening. Surprisingly, you will not get any major difference. Okay, that formula is not sensitive enough to do that. Okay, and next, and then we try to do a historical analysis and timeline before the construction of any breakwater. Next, during after the construction of the Ennur port, then with addition of the Kottapalli port, what has happened. So, earlier there are some minor accretion or minor erosion, otherwise it would have been a accreting coast. It would have been an accreting coast. This has been an accreting coast because this Ennur Creek has been only during the monsoon time, it delivers lot of sediments into the sea. All these sediments has been drifted top and accreted, except at some point some minor accretion, erosion, it nothing in doing. Now, this 1919 to 2009, there will be a large erosion also been accumulated. This is as per the prediction. However, in actual sense, here it will be all are green, this particular area. We have already so much available nourishment is there, sand bank was there, but still on the northern side there was less accretion. Then after the completion of the Kottapalli port, again this got full accretion, and here of course it was already accreted, and this becomes the eroding coast. Now this is continuously been eroding coast in a larger rate. What will happen in the future is again the things. So, this is the overall change. what is the net gain or net loss. So, net loss is only on the Kattupalli port compared to the other two regions. Okay. So, net is always not 0 due to many reasons. What are the reasons here? Net loss and net gain should be 0, correct, for conservation of mass. Conservation of mass is not working here because of the port activities, dredging. We are taking away the dredging. With the dredging one, we are depositing somewhere in the offshore. They make sure that it is not coming back to the coast, otherwise it will add to their dredging cost. Okay. Now, what we try to do, we try to make a statistical algorithms for the future prediction. Always it is possible, we can make so many data sets. Now, we are also adding a AA and ML. Earlier all statistical use only, even if you say neural network, all those things are totally okay. All neural network, if you do not know what is it doing at every step, no point in using the neural network. Training the neural network and testing does not mean anything unless you know the neural network, what are the type of the neurons it is picking up. If you are not feeling it, there is no point in giving to neural network. MATLAB has so many simple subroutines, many routine subroutines are there, no point in running it, neural network. So, nowadays of course the better tools are coming with AI and ML, and with poor understanding also many of the AI ML tools are much better than the so called the neural network what many of them has applied. I think at least this generation next last 2-3 years I am seeing many of you are taking AI ML tools rather than the neural network tool. Of course, AI ML tool also been basically built over the neural network, if you see the basic mathematics behind it. Now, this prediction, say shown in 2010, how it is gone to 2019, and we try to predict further with the same rate at which 2030, another 5 years, how it will be like that. There will be a from 2020 to next 10 years, how it is going to be there if you are not doing anything. And we are also not doing in the north of the Kattupalli, one of the very simplest reason that there is no inhabitant is there, either the fishing village or any of the development are not there. Once some development is there, we will also try to do something, so otherwise it will get sacrificed. Okay. So, next I am going to a next one, and the Kerala coast. Kerala coast is one of the very important thing that it has a many number of estuary, river or backwater outlets into the sea. So, it has compared to the east coast, Kerala coast, many of these openings are permanently open 365 days. So, it either delivers during monsoon time, of course the huge flow also supplements the sediment, and also during the other season lot of tidal water flushing and flush come out, that means tidal prism is maintained, that is what most of the time mouth get open. However, more and more activities, earlier only it was a fishing activity, and a fishing activity even some few weeks a year, if it is closed they do not bother, cut open for manually. But nowadays there are even some minor commercial activities are also we are doing through the waterway. So, that is what we are trying to make a all mouth to keep it open. All mouth to keep it open, one of the simplest solution is construction of a pair of walls called the training walls, so that we keep the mouth open. The keeping the mouth open formula is quite simple, and what the flow coming from Q from inside and the amount of sediment transport M, either this or that, I am not going to comment because Kerala coast is one of the very complex. I cannot define towards always towards north or always towards south, both are not at all the correct statement. So, either south or north Q, the relation between Q and M dictates whether there will be a sediment deposition here or not. Okay. So, between that we can always make a prediction whether sediment is going to deposit at the river mouth, and if sediment is going to deposit, how can we make a mouth to open throughout the year. So, that is what one of the simplest thing is. Many of the outlets are supplemented with the training walls. So, this is one of the training wall constructed. Say if you can see the images from 2011 to 2020, and this is more or like a more stabilized training wall in the Kerala. Such a kind of stabilized training wall along the east coast is very, very difficult to get, okay, because there is a balance in the west coast, that balance is missing in the east coast. So, what because it is working in the Kerala, I cannot implement same thing in the Tamil Nadu, okay, that you have to always keep in mind. So, all these examples are unique to a particular case study. Now, of course, similar to any other place, huge sediment on both sides, and of course, in this particular area, and sediment drift is from north to south, south to north, this area. So, that is what over the years there will be it is sediment starving on the northern area, this is north, and this images shows more or like this has a very permanent closed mouth. So, I am going to talk on a slightly in a different fashion than the earlier one. So, what we try to see, the rate of accretion or the rate of erosion or rate of the sediment rate, one based on the shoreline position, another based on the slope, beach profile slope, both are very, very important. Sediment shoreline alone most of the time we are satisfied with the imagery, but beach slope we have to go and measure it. Both are very, very important in many aspects, and it is expressed with some statistical measures how the outside accretion. So, now this particular case helical training wall gives the accretion at both ends almost of positive, that means all are accreting coast, no erosion, but still the mouth is kept open, The training wall success is one when there are pair of training wall is there, shoreline, this sediment should not get bypassed. If it is not bypassing, our design is good. However, this is one success, another success, and the other place there should not be any erosion. If there is no bypass, but another place it is a erosion, we are failing. So, there is no point in keep on increasing the length of the training wall one side, and there is no point in cutting the training wall at another point. Increasing the length of the training wall makes the sediment and erosion on the other side. However, if you are limiting to a particular area, sediment will deposit. So, this condition is contrary to a particular construction of the groin. Then we will talk in a different angle. So, there will be a challenge of the training wall. So, we tried to analyze most of these one using the similar kind of analysis about more than 70, nearly 17 training walls we tried to analyze both from remote sensing and the field measurement. And most of the time these are very, very important, particularly for the training walls, and because if there will be a accretion or river mouth closure is expected, then what we have to do? We have to do a precautionary measure, not after it happened. So, if there will be a erosion or there will be if I am predicting a river mouth closure, then assuming that if it is from south to north accretion, I can make a sandbar, I make a artificial dredging there, so that I will make a pit for the sediment move here and deposit there, which is one of the important like many of the major harbour does. Many of the major harbours they do a sand pit which act as a cushion, so that sediments will not bypass into the harbour. Same thing that we have to do it, which we can make it judgment if you are regularly having a monitoring of the training wall. Okay. And then another important aspect on the training wall, this what we are talking about from the only on the seaside. Similarly, breakwater is only from seaside is enough, but training wall the problem is with that from the river side, this is sea, from the river side huge sediment comes. Most of the time this sediment comes during the monsoon time. Once it enters into the open sea, if it is a training wall is not there, immediately on the shoreline itself will open to the sea. See, it sees a wider water body. So, the velocity of the particle velocity becomes suddenly drops. So, immediately it deposits. So, this deposition is also a highly dangerous, because next this monsoon will happen 2 months or 3 months, particularly in Kerala coast will be very active in 3 months. Another 9 months we have to live with along shore transport. Okay. Monsoon, Kerala has a unique thing, one large sediment from the river, another one hugely it is onshore offshore transport. I can say 100% 3 months period Kerala coast will be onshore offshore, balance 9 months it will be along the shore. So, the modeling also uniformly we cannot make a same rule, we have to trigger the rule, otherwise it cannot be done. So, all these things we can predict if you are continuously monitoring the training wells. And one Karaikal, we made a very systematic thing, we have Karaikal now coming to the east coast. All logics will not work out in the east coast. So, Karaikal there was a training well, and we tried to study more than nearly 1 decade. Nearly 1 decade we tried to analyze of different thing. And so, of course, the beach profile, and one of the basic necessities shoreline profile, that is how the shoreline is there every season or every month or every season, and to the cross section. Cross section and the shoreline profile speaks lot. Entire modeling you can live with that with your mean sediment diameter. These 3 data are there, most of the time you can be very successful, and this is enough for even tuning the most of the sediment transport model. And now I have to make whatever I am discussing is sediment transport with reference to wave action. Sediment transport with reference to wave action, wind is not added. If there is a wind induced movement, I will take it as a source or sink into my model. Hydrodynamic will not play a major role when I am talking about the shoreline. Hydrodynamic is very important when you want to estimate your dredging or the siltation in a harbor basin or siltation in the entire area. Hydrodynamics is very important. And in the earlier one, the river mouth, this siltation, how much siltation is going to throw here is purely on the hydrodynamics. It also tide also be playing a major role, but once it is throwing it out, our along shore transport or the cross shore movement play a major role to drift that sediment. You have to make a combination, where to couple is very important. And ASSA now explicit coupling, because there is no point in doing implicit coupling, even explicitly also any model is not perfect. So, no point in doing implicit coupling, do not take more effort making a implicit coupling, making an explicit coupling of each. And beach profile changes, seasonal changes we try to predict over many years. This is about nearly 1 year, exactly 1 year, and ultimately what we are trying to derive it is only I am trying to say, and you say erosion accretion patterns. And Karaikal, one of the important part that we have taken is, otherwise all other east coast of India, if you take training wall, most of the time river mouth get closed. Karaikal region is the one, nearly it is at the starting point. Nagapattinam is almost 0 sediment transport if I say, Karaikal is next to it, just it is picking up that area. And because we also measured the other angle here, large inundation area, because Karaikal region is a very short, very small along the coastal region, and more than that, high tide time there is a coastal band. If the coastal band, if I chop it off, most of their agricultural land can get submerged. So, that was most of the time cyclonic time, entire their agricultural land in the along the coastline will get submerged, which makes their land unusable for at least for next season. So, that is another important part where we took it. We also added the inundation, which I am not presenting it. So, we try to merge both. Now, erosion accretion pattern is very important, so that we keep the mouth open throughout the year here. Initially this Karaikal, that is Arsala river mouth, was not so stable like this particular region. So, as soon as they constructed nearly 2 decades back, this got open. Nearly this opening persisted for few years, they could not resolve it. Because it got opened, they got lot of siltation here. Because flow got diverted here, almost nil flow, all the sediments got settled there. This siltation is coming from the river itself, not from the open ocean. Okay. So, of course, the reversal happened slowly, naturally, they did not do much action on it and on the engineering sense, but slowly it got reverted, and luckily this happened. Normally, if such a kind of breaching out happened, it will never come back unless we intervene engineering sense some angle. Okay. Now, I am not going to take much. Of course, all grain size distribution is very important here, and I will not discuss it. And the cyclone impact, I will tell you, because the futures another site also I am going to talk about the cyclone impact. The cyclone makes a flat slope into a steeper slope. This goes to the next steeper slope. This is the seabed. And this impact has a secondary impact. When it becomes a steeper coast, that means this is your waves in the shallower one, steeper one, again larger waves come. Why? Steeper coast, larger waves come to the coastline compared to the mild slope. Why? Water depth. So, all your breaking wave height, it depends on the water depth. So, it will pick up shoaling, more larger the wave height, and not only the larger wave height, that larger the wave height breaks very near to the shoreline compared to the flat slope. So, steeper the coast, again we are accelerating the erosion, or that means more energy is coming to the coast. So, cyclone makes this significant impact, but there is a natural healing. Whenever there is a cyclone, if you go immediately mild slope to steeper slope, you will get. You go to the same coast after 3 to 4 weeks, that is more than enough. You will come back to this, or you will try to retrieve, if not 100%, at least 80%. This is a natural healing. Okay. So, that here one point of thing is, when it is becoming a steeper slope, whether to take the decision or making a mild slope taking a decision is quite challenging. When we are doing something, it can be anything, it can be intake well, or it can be a coastal protection, does not matter. There are two aspects we have to do. All your planning should be on the mild slope, okay, in terms of the layout planning, etc. And all your structural design based on the steeper slope. There are two aspects, one is the layout planning and structural design, and you have to make a dual rule, and either way if you fail, ultimately structure will not fail. We need both, functionally it has to satisfy and structurally it has to be stable. And if you are designing everything for steeper one, your functional performance efficiency will be much less. If you are everything doing it for flatter slope, functionally it starts behaving very well, next cyclone etc., it will collapse structure. Most of the time that is what happening. We do not wisely do such a large variation is there. If such a large variation is not there, we are happy. Okay. Many places such a large variation will come, and most of the time what will happen is most of the time immediately as soon as cyclone comes, people agitate, then immediately go for the measurement, do the design. So, that means structurally it is good, structurally it will be stable, that is what most of the 99% of our structures are studying very well without doing its performance. It is not that your design is not, we cannot say it is not correct, your design is correct, but your database is not correct, your input is not correct. So, ultimately we have not applied to our mind. So, this major difference functional to the structural, that we have to keep in mind. Both are very important. Failing one, no point in achieving a very good structural stability without a functional achievement. Vice versa is also true. If we started a very good functional achievement, suddenly structure collapse, then all of them will get disappointed. Okay. Okay. So, and I will take a Talanguda, which is just another 50 to 80 kilometers north of the Karaikal. This area, there was a seawall. Here this area is quite interesting because there is a two both are substream of the river, Tenpanayar river, but there it joins and this stretches in between the sandwich in between the stretch, very short stretch relatively. There was sea wall at few stretches here and here, sea wall. This has been severe erosion, and one way such a kind of water body is there. One way we can make an easy to model, or another way is difficult also, but easy to model in the sense that the sediment transport we can as always assume it will be restricted to mouth, but provided this is only true when mouth is fully open. Another complexity is there, how much sediment is coming out of these two streams are unknown most of the time. Nowadays it is easy for us as engineers because most of the rivers are blocked somewhere at the top, no sediments are coming out. So we can easily model it. All our models will do perfect calibrate, or your field measurements you can easily calibrate. You can always proudly say 30 years back their model did not do the good result, I am doing the good result. It is not that you are doing the good result. Yes, we made you to get a good result by blocking the sediments. Okay. So if you are doing good result, that means something is mistake. And now this beach profile changes etc. We try to see a cyclone and post cyclone and pre cyclone, and very interestingly many places this is near the shoreline. All the sediments, say here you see a post cyclone is a dotted line, sediment there is a erosion, but here if you see all are accretion. So same observation you can also get if you do a field measurement pre and post cyclone in a particular stretch, same thing will happen. Cyclone is not stealing our sediments away, it takes and deposits the near shore, of course in sense offshore, but it is a very near shore. That is what our regular operational season, this is coming back to the coastline without any time. That is what I told you, 3 to 4 weeks. This has a lot of evidence. Even then North Chennai also we made a 1 year continuous measurement, we also have seen similar phenomena. So this is a unique phenomena. So this sediment is going here, that means cross shore movement, cyclone onshore offshore movement, that is evident. Now how this sediment is coming to the near shore is due to the along shore transport. Your conventional formula, wave is breaking here, a wave is breaking here, and which makes it releasing a lot of energy, it picks up the sediment and along shore drift moving and depositing on the shoreline. So here also a combination, while you are modeling a cyclone you are going to apply a cross shore sediment transport model, but now all the other time you are going to apply a along shore transport model. Okay. This is for east coast of India. Okay. Now this is most of the things, because wherever the sea wall is there, the steepness of the beach has been increasing, other places it is depleting. And I will not take you much time, because later they want a permanent solution, there is a groin field has been constructed, this area got stabilized without not much erosion, I am not going to talk about. Okay. One very interesting one, Chilika. Okay. So this also I am taking an example, and whatever done is also engineering. Okay. Chilika Lake, all of you, many of you know, correct? Chilika is the largest coastal wetland of India. Okay. This is more than 1000 square kilometer. This is an entire water body, and all of them are joining through a so much stream along the entire length. What will happen is that, say the light blue color is at water line, and this entire area, what will happen is somewhere here to here the mouth will open at various months of the year. Slowly it drifts to north, and during the month of June it opens here, heavy monsoon, and then month June to September this oscillate very near to it, after the September it slowly drift to the end, and sometimes it will get closed. But because of the Chilika Lake large body, even if it is at closing, it has sustained, but the problem is the exchange of water, that is a tidal water was missing. Hugely we are losing the balance, particularly the biological balance in this particular area. So, it was referred, many institutes have studied, okay, how to make this mouth open. How to make the mouth open? Training valve. Good. So, the final solution was made, no training valve, just cut open for sufficient width and sufficient depth. The channel should be sufficient depth. This is the only solution, and it was made with a lot of debate, etc., and final things were made, and of course, this will not have a not much cost also they can make it, because anyway they are trying to cut open a smaller opening most of the year, so that exchange of water is there. Now it is defined to be a particular design water depth with a width. This has been done, and this has made a very sustainable solution even now. This has made now I think nearly 12 years now. 12 years the mouth is still opening at the same point. There is no drift also, and after that they have a I think nearly many-fold of this so called the bio species high, etc., etc., etc. Now they are reporting a multi-fold higher increase. Now this is a without doing anything also I can say this is an engineering solution. Okay. So when you are doing a thing, we have to also think across the paper, not just sea wall, groin, training wall, breakwater. This is not the solution at all. We have to think beyond the thing. Artificial nourishment is definitely a solution, but many times it is not at all possible. Wherever it is successfully done in India also, artificial nourishment failed after a few years or after a few decades. Vizag has failed after a few decades, and immediately after a few years it failed in the Puducherry harbour. And so, how it is a sustainable solution, that is a very, very important part. Okay. So, this is a coastal protection, simple. So, Voyalicopum is just south of the Chennai, I am just taking this example. It is designed to be a east coast, close your eyes, if you design the groin, definitely it will work, whether the response will be immediate or later will be the okay, but definitely it will work, and only the thing is how you are going to do. So, the estimate is now you are going to whatever you have studied, offshore wave climate, then you have to derive the nearshore wave climate, then further take it to a alongshore drift calculations. All of you have the formula now, there are so many formulas are there, I do not know. CRC definitely you have studied, correct? CRC is one of the standard, and Comar is a much older one, and kind of a distribution, that one is studied, no, okay. So many equations are there, more than 100 equations are there, okay. CRC is well accepted, provided you tune it. So this is nearshore wave modeling. Nearshore wave modeling you have to do in it twice. One, without any structure, how the waves are getting diffracting or refracting and shoaling, all this one we have to capture it. And my important stakehold here, I want to make sure in the presence of the structure there should not be any convergence. This wave and this wave go on, should not converge at some point. If it is divergence, it is okay, because ultimately groin is my point where we need to make a sediment to deposit, but it should not get converged. So that is one of the point. Most of the time many of you have seen kind of a, this is a wave crest, every yellow line or every green line you can assume make a wave crest, another thing will be wave trough, how the wave is moving and doing it, and this is the energy distribution, or wave height. So wave height gives you the concentration of the energy, but more than the thing I am more interested in seeing my contour, because all this wave modeling more than the laboratory you can exactly predict in the numerical. If you are trying to capture the image in the field, and here it will perfectly match. So this nearshore modeling and lateral transport estimate, finally you can also make a shoreline evolution. So your lateral transport and nearshore modeling will not come into the picture of the shoreline evolution, but your littoral transport will be like a source. That is a source. Then your shoreline modeling, which is a one line model only. So far even one line model, not more than that. A simple one line model, all that is a first order differential equation. All of us studied in the max in the school itself, solving the first order differential equation, that already was done long back. That is only the thing it is going to predict. And say here this example, okay, these are the structural design. Within the 6 months we got so much sediment. Okay, this we never experienced in any other place. This is just south of the Kalpakam, and all groins almost like a fully filled and also sustained the monsoon, next monsoon, and unfortunately similar to the end effect, after the last groin and entire erosion is happening, but luckily Kalpakam has full of seawall, very strong seawall that has sustained their Kalpakam region. This is towards the end if you see this part. Yeah, the last one is thing. So here, there it is a erosion, they have a very strong seawall, it has sustained, but it is not that I am not happy because this slope is getting steeper and steeper every year. Okay. So we are also trying to tell them you treat that coast, otherwise this long time it is not sustainable. Steeper the coast, that makes larger waves comes during cyclone time, entire area will get inundated. Okay. So last one I quickly cover, and there are in the Gulf of Mannar there are a group of 21 islands, all are ecologically sensitive islands. Okay. And again I am telling that whether the engineering, in terms of the engineering, all places, all sediment transport model etc., you can use it. Finally you have to relate your model to the what you are trying to do. All ecologically sensitive thing, in the entire area even fishing is not allowed. So that means we cannot do something. Here the problem is that one of the island, the southernmost, is called the Vaughan Island. So Vaughan Island, it starts degrading from 16 hectare in 1986 to 2015 1.53 hectare, and this much big has degraded to a smaller one. And due to many reasons I can put it, and in record or off the record etc., there are so many reasons are also there, and whether without human intervention or with human intervention, everything we can put it, and I am not going to do for that. And how to protect is one of the biggest question. While the no fishing also allowed, we cannot put any engineering structures, and we try to see in the nearby. So they try to do a lot of coral rehabilitation in this entire area. One thing captured our idea, I think, is this triangular wedge they are using for coral rehabilitation. We try to replicate this structure, make it a trapezoid, same porosity etc., make it a trapezoid, and we try to use it as a wave energy dissipator. That means same structure being used, that means allowed this kind of structures they are using for the coral planting, artificial coral planting in that particular area. Successfully they have been employing for many institutes and many applications. And the only thing is how these blocks are placed in a particular spacing, width etc. has been designed with so many numerical cycles. Finally 2 rows with a kind of a detached breakwater submerged part has been designed, and one of the very important part is that how the wave energy is dissipated while entering this point, while approaching the island. That was the only thing, nothing else, no sediment transport calculations are made, and we try to see how to dissipate the energy so that further degradation of this island should not be happen. That is the only objectives, all these were made. Okay. And structure is also been the so called environmental friendly, that means accepted to be environmental friendly that particular area. Then it was casted in the research mode itself, not like a full commercial mode, and it was placed, and of course a lot of corals naturally has come and fitted into it. Yes, there is no artificial planting in this structure, that also added to the entire system. Now it is sustained, and also it started gaining the northern side whatever the lost. Okay. Now Here there is no sedimentary transport calculations, similar to a groin. By construction of the groin, how the sediment is moving, there is no calculations, and ultimately what we are trying to see here, we are trying to alter the driving force, try to alter the driving force. I can also say tell in the first one of the reason that the altering the driving force only has made this island degrade. Altering the driving force accelerated by removing all the other corals in the neighborhood area, but the driving force has been altered because of the few kilometers long Tuticorin port. It has changed its wave direction, not energy, because northern part of the towards the Gulf of Mannar, etc. If you see, always it will become, always it will become, not much. Wave direction has changed. Something has changed, equilibrium has to change to the next level. That is the reason. So, be vigilant on the all your driving force component, not only the energy, direction, etc., etc., more than the even transport calculation, because transport calculation mathematically it is quite simple. Transport calculation mathematically it is quite simple, it is not going to give you additional thing. Okay. So, with this I will stop, I will not go into much deeper into it, and once we are started doing this, once you are in the job, always you are having continuous jobs. That is that advantage of the coastal engineer. You are going to disturb, create your own job. All the very best. I think some of recently we have the coastal engineering textbook, many books. This coastal engineering theory and practice written by myself, Sundar, has lot of input materials also. Okay. All the very best.